Hi there, my name's Jason. Welcome to my digital design project. This is the first time I've had an attempt at making a video and going to post it online. Today what I'm going to be talking about is the digital BASYS 2 board, and particularly the FPGA, which is a field programmable gate array. It's a chip which lives right in the middle of the board there, and basically we can manipulate that to come up with any circuit design we want. One of the other beauties of that particular chip, or an FPGA, is, as the name says, it's field programmable. You can manipulate circuits on the fly in the field as you need to, which gives you a great advantage and a lot of money saving too as far as costs to develop a circuit. So you can do all your testing and everything with the use of your software, interacting with the board and making sure it works before you go into sort of production of a more permanent chip. Okay, so now I'm going to introduce you to the software, in particular the ISE design suite, which allows us to create the circuits we want to build and eventually implement onto our BASYS 2 board. Now what you'll see over here on the left hand side is what we call the top module. Now what's happened, the counter's been divided up into separate modules, so there's X1, X2, X3, X4 and X5. Now one of the reasons for doing this is so you can sort of individually address each section of your circuit which drives a particular part of the board. It's easier to troubleshoot the board in this way. If you're having problems in a particular area, you can just go and manipulate that area. And each one of these you can create what's called a test bench for each one, and simulate the actual outputs that you get for particular inputs of that circuit. Now the top one up here is the one really that ties the whole lot together. Just one other point of note is down the bottom here we've got what's called the user constraints file. Now over here to the right hand side you'll see, now these are the switches I've used for my project. All we're incorporating is switch number 1, switch 0, button 3, and this A through to G here is for the 7-segment display, along with AN 0 through to 3, which is providing the ground, if you like, to light up the 7-segment display. Alright, now what we'll have a look at, the one that I've manipulated the most, I guess, is the counter itself. Now what I've incorporated into this is a stop function. Alright, up here we've got sort of all your inputs and outputs for each of the modules, well for this particular module in this case. So you've got a signal coming in from the clock, you've got an external direction coming in, that's an input from one of the switches which I highlighted before in the user constraints files. Reset, which is the button I've used in the user constraints files, and the other input is the other switch I've used to stop the actual count of the counter. Now if we go and have a look back at the countertop, this has all the behaviourals of each of the segments, so that the countertop's there, the clock divider, which is X2, is there. What else have we got? The 7-segment, the mux, etc., etc. All your input signals are defined in here. Now the one I wanted to draw your attention to is this one here. Now this is the one that actually tells the circuit the direction will be manipulated by switch 0. Okay, you can see down here stop, which I've got the stop on switch 1. That'll actually stop the counter from progressing forward. Now if we go and have a look back at the counter, the actual process itself, so we've defined the resets, the stops and the directions up here, and then we have the process which tells you how the circuit's going to respond. Alright, for example, if direction equals 0, the counter is going to count up, so that's your count number and it will count up 1 each time. If it is not 1, then the counter will count down. That's your starting count number minus 1. Alright, if you use stop, so if I switch that stop and it puts a high on there, the count will remain at the count. Alright, that pretty much gives you a brief overview of how the actual programming of the circuit works. From there, once you've sort of got to a point where you think everything should be up and running, you have a couple of options. You can create test benches and simulate the circuit, but when you want to actually put it onto the board, you need to synthesize the circuit, and then we generate a program file. Once you've got all the ticks in all these, it'll check for errors, etc. When you get the green light, you can generate a program file, which is a bit file. Now the bit file, we'll start another clip in a second, and I'll take you through that. That's what we're going to actually implement onto the board, so we can physically start using this circuit.
Let me know just before you start.
Oh, that was now. Sorry. Okay. All right. One of the sort of final steps to get our program or circuit design onto the board is to use the Digilent Adept software. Now what this does, I've got my board plugged in there, and it recognises the chip that's on the board. As we mentioned right at the very beginning, it's FPGA 3E. Now I know it's a chip I want. All I need to do is browse. Now I don't think you'll be able to see that, but I've just chosen the counter top, so that's my counter. I'll program. Now what that gives is an indication on the actual board that's plugged in, a little flashing light saying it's good to go. Next I'll take you over to have a look at the board actually in operation. Okay, so what we're looking at here is the BASYS 2 board, and in particular the FPGA Spatan 3E chip in the middle here, which is now being programmed up with our circuit design. Now, as discussed earlier, the circuit is designed to give me a hex counter over here, and I've programmed a couple of the switches. So switch 0, which is this switch here, is controlling the direction of the count, so whether it counts up or backwards. And switch 1 over here is actually, when we put a high on it, as it is now, it's enabling us to freeze the count or stop the count. And now that's been set up all in the software. Button 3, this button down here, that one allows us to reset the counter to 0. Now within the programming itself, I have also manipulated one of those modules, which is the clock divider module. Now that's just changing the speed of the count, so you can do that by manipulating the frequency that comes in. Now what we'll do, we'll do a bit of a demonstration. So I'll put that down so it can count forward, and we'll take the stop off on switch 1. So it's going to count up. Notice it's going to hex. Alright, now button 3, as mentioned, should reset to 0. There's our reset to 0, and away it goes again. Now I have the option of using switch 1 to stop that at any point. Once again, I can reset that back to 0. We can let that go again. And switch 0 allows me to manipulate the count to go backwards. Alright, so that's it on the functionality of the actual board itself. Thank you.